Hi, and welcome to a second video lesson on solving exponential equations using logarithms. Once again, we'll be using the definition of logarithm. So we will take an equation that is in exponential form. We've got a power that is a base a to an exponent c is equal to some answer, and we'll rewrite it in its logarithmic equivalent form. Log with a base of a, the same base that's the base of the power, and of b is equal to c, the exponent. And so we'll also be applying that change of base formula for calculating if we want to estimate these logs. So if we take a look at this first problem, solve for x here with 3 to the negative 2x plus 5, all minus 10 is equal to 6. Notice this isn't really of the form a base to an exponent is equal to some number. We've got this minus 10 involved. So the first thing we're going to want to do is add 10 to both sides of that equation. And that'll give us 3 to the negative 2x plus 5 power is equal to 16. And now, while it doesn't necessarily look like it, that is of the form a base. A is like the 3. And then the exponent c here is that negative 2x plus 5 is our single exponent. Even though it's not just a number or a letter itself, it's an expression. But there's a base to an expression for an exponent is equal to 16. So, c is like our negative 2x plus 5, and of course then b is like 16. So this is going to be the log base 3 of 16 is equal to that exponent negative 2x plus 5. Now the log base 3 of 16, I'm not sure what that is exactly. There is some irrational number that's equal to. I know that 3 squared is 9. And I know that 3 cubed is 27, so similar to the previous problem, that's going to be 3 to some number between 2 and 3. 3 to the 2 point something, or 3 times it's going to be 2 point something, what this is. But I'm not going to do that. I'm just going to leave it as log base 3 of 16. That's kind of, I guess I'll put that in brackets. That is just some number that I'm not sure exactly what it is. But that doesn't keep me from solving for x. I'm going to subtract 5 from both sides here. So I'm going to take that, and that'll give me log base 3 of 16 minus 5 is equal to negative 2x. And then to solve for x, I'm just going to divide by 2, like I would. Had I known what this number was. And of course, I can't subtract 5 from a number that I don't know, so I'll just leave it as log base 3 of 16 minus 5, and then that will give me x, and x will actually equal this. This is my expression for x, and that's an exact solution. Now, of course, we know that if we want to approximate x, we can then, on our calculators, go up and find the log base 3 of 16. Now remember, the log base 3 of 16 is the same as the log of 16 over the log of 3. So on the calculator I can put that in. And then I'd subtract 5 from that answer, and then from that I would divide by 2. So I guess I'll do that on the calculator real quick. Log base 3 of log base 3 of 16. And so, oops, I've lost my calculator. Second. So I'll get my calculator back. And so that's the log of 16 in parentheses divided by the log of 3. And that equals that number, 2.523. Now I'll just take a moment here and say, if I'd have done the natural log of 16 and then divided by that ln, the natural log of 3, it'll give me the same exact number. So as long as you're consistent, you use the common log, log, or the natural log, ln. So that's giving you 2.523. Now I'm going to subtract 5 from that, because that was what the numerator said to do, right? If you take a look at that, it's natural log base 3 of 16 minus 5, and I get that answer. And now that answer divided by negative 2. Now again, you can't really put negatives into most calculators by pushing the subtraction sign. There is usually a plus minus key in there somewhere that you can, it's a change of sign key. But in this computer calculator, you can use the negative, the subtraction sign is a negative. That normally can't be done. But anyway, there's our answer, 1.238. If we just went out 3 places, that'd be 8, it would round to 8, 1.238. So I'm just going to approximate that, and of course 1.238 is just an approximate answer. This is our exact answer over here, right? And this is an approximation. Now, let's move on to the next problem. And it is similar, only this side the variable's on the right-hand side. It doesn't really matter where the variable is, We're still looking for something like b is equal to a to the c power. That's still going to give us log base a, the base of a, of b, log base a, is equal to c. It's always equal to the exponent, right? The logarithm of something is the exponent, okay? So notice this isn't got an a. This has a coefficient. It looks to me like 2 is like the base of the in this power. 2 is the base in this power. So I don't want that 96, so I'm going to divide both sides by 96. And so let's put that over there. Dividing both sides by 96, 12 over 96 happens to be 1/8. And that gives us 2 to the negative t over 8. And that is looking more like that form a to the c power equals b, where a would be 2, c, the exponent, is negative t over 8, and then b would be 1/8. And so if I rewrite that as a logarithm, that's log, and again, the base of that exponent power is a 2, so that's the base of my logarithm. And then 1/8 becomes my argument, and then, of course, the exponent becomes the answer, t over 8. In the last problem, you may notice I wasn't sure the exact value of log base 3 of 16. That was some irrational number, right? It was something between 2 and 3. Well, log base 2 of 1/8 is a little different. If you try that on your calculator, right, take the log base, log of 1/8, this is the change of base formula, over the log of 2, you will find that that is equal to negative 3. Because I know 2 to the 3rd power equals 8. And so if I make that a negative 3rd power, that gives me the reciprocal of 8, right? If that's a negative, it gives me 1 over 8. So that's going to be a negative 3, and you can do that on your calculator if you plug that in. And then that equals the opposite of t over 8. And now to solve for t, we want to multiply both sides of this by something that will get rid of the negative. So that's going to be a negative number to cancel that. And then dividing by 8 will multiply by 8. And so that'll get rid of the 8s, and it'll get rid of our negative signs. And so over here we have to multiply by negative 8 as well. So that gives us 24 is equal to t. And here we get a nice exact value. Okay, I hope this video was helpful. I'll see you in the next video.